This will be a short video to explain the concept of the powers of I. So the first power of I to the 1 power, is the square root of -1 as we know. Now we've talked about how I squared is -1. I won't go into an explanation here of why I squared is -1, but suffice it to say that when you take the square root of a thing times itself, you get the thing that's inside the square root. Now let's look at the idea of I to the 3rd power. I to the 3rd can be written as I squared times I, and since we saw that I squared is -1, that simply makes that become -I. So I to the 3rd actually reduces to -I. And finally, let's look at I to the 4th. I to the 4th, there's several ways to prove this. I think the simplest is to rewrite I to the 4th as I squared times I squared, which is I to the 4th. And we know that I squared is -1 times -1, and -1 times -1 is simply 1. So what we'd show here is that every time you multiply I by itself 4 times, you get back to 1. So if someone asked you what is I to the 5th power, you could simply say that that is I to the 4th times I. And whenever you see I to the 4th, that's simply 1. So multiplication by 1 allows us to mark through that. So I to the 5th is the exact same as I. And so this problem goes on every time you have 4 I. So it's potential we have a question that would say I to the 40th power. And so typically the approach you want to see is how many 4s of I are in 40. How many 4s are in 40? And there are 10 4s in 40. Alright, so what that means is I can write this as I to the 4th multiplied by itself 10 times. So I to the 4 to the 10 is the same as I to the 40. And as we just saw, I to the 4th is 1 to the 10th, and 1 times itself 10 times is still simply 1. So I to the 40 is just 1. Now let's back up 1 from there. What about I to the 39? So we try again. Let's see how many 4s there are in 39. Well, 4 goes into 39 9 times with 3 left over. So we can express I to the 39 as I to the 4th raised to the 9th. That is I to the 36. And then we have 3 more I's. So I to the 4th to the 9th, I to the 4th is 1. Raise that to the 9, that's still 1. So I to the 39 is the same as I to the 3. And I to the 3rd power, as we saw over here, is -I. So I to the 39 can be reduced to -I. One final thing that you might see is, what if you had I to the -13? You may have forgotten what negative exponents are. Negative exponents allow us to express powers in a way such that when they are in the other side of the fraction, they become positive. So I to the -13 is the same as 1 over I to the +13. So again, let's see how many times 4 goes into 13. 4 goes into 13 3 times with 1 left over. So I can write this as 1 over I to the 4th to the 3 power, and then 1 more I. So that is 13 total I's, and I to the 4th is 1. 1 to the 3rd power is just 1, so that is eliminated. So we have 1 over I, and as we saw in previous problems, we can't have I in the denominator. We need to process that. And there's several ways to go about doing this from here. I'm going to multiply by -I. 1 times -I is -I. And I times -I is -I squared. And this is the reason I chose to multiply numerator and denominator by -I. -I squared is negative, and then I squared is -1. So double negative of 1 makes it 1. And so the final answer for this one is simply -I. So as you see, no matter what power you raise I to, you will get one of 4 answers. The answer will either be I, -1, -I, or simply 1. And I hope this video explains these powers of I.